Good day, everyone. Our topic here is on circle. At the end of the lesson, you will be able to define a circle and determine the equation of a circle. Let us define circle. Let's see be a given point on the plane. The definition says the set of all points having the same distance from C is called a circle. The point C is called the center of the circle. The common distance r is radius. Let us remember that a circle is determined always with center and radius. The center is denoted by parentheses h, comma, k, and then close parentheses, where h is the x-coordinate and k is the y-coordinate of a point, and radius is denoted by r. There are two standard forms of equations of a circle. The first one is x squared plus y squared equals r squared. It is written in this form if the center of the circle is at the origin of the Cartesian plane, which is 0, 0. The second equation is the quantity squared of x minus h plus the quantity squared of y minus k equals r squared. Take note in here that x is subtracted by h and y is subtracted by k. Take for example this figure. The circle has its center at 0, 0 and radius r. The value of r cannot be determined easily if we look at this line segment. But if we investigate further, the circle passes through the point -4, 0. Thus, it gives us an idea that approximately r is equal to 4. So, the equation of this circle is x squared plus y squared equals 16. Let us consider the second standard form of equation of a circle. The quantity squared of x minus h plus the quantity squared of y minus k equals r squared. The circle can be illustrated in any of this form. The circle can be illustrated with its center at the first quadrant, or it could be a circle with its center somewhere in the second quadrant, or its center could be in the third quadrant, or its center might be along one of the axes. For example, if the center is at the point 2, 3, with r equals 5 units, then its equation is the square of the quantity x minus 2 plus the square of the quantity y minus 3 equals 25. If we wish to manipulate the operation or simplify the equation, then it can be done by squaring the quantity x minus 2 and the quantity y minus 3, such that it gives us the quantity of x squared minus 4x plus 4 and or plus the quantity y squared minus 6y plus 9 equals 25. Simplifying further by eliminating the parentheses, equating this to 0, we have x squared minus 4x plus 4 plus y squared minus 6y plus 9 minus 25 equals 0. And finally, writing this from the highest degree, we have x squared plus y squared minus 4x minus 6y minus 12 equals 0. Thus, we have it in the general form of equation of the circle. With that, it gives us an idea of the general form of equation of a circle. bx squared plus ay squared plus dx plus dy plus f equals 0, where a, b, e, and f are integral coefficients. Take note that the coefficients of x squared and y squared are numerically equal, and we do not have a term here with the product of x and y. Let's have examples in circles. Number 1, write the equation of a circle with center at -1, 4 and radius 6. Since the radius r and center xk are clearly given, then the equation of the circle in standard form is x minus -1 quantity squared plus y minus 4 quantity squared equals 36. Finally, we have the square of the quantity x minus 1 plus the square of the quantity y minus 4 equals 56. Number 2. Write the equation of the circle illustrated in the figure. The figure shows a circle with center at 3, 1 and passes through the point P at 0, 2. To have the equation of the circle, we need the center and radius. From the illustration, we already have the center, but we do not have yet the value of the radius. Note that the radius r, or the distance of the segment CP, is solved through the distance between C and P. To solve the distance of the line CP is to use the distance formula. The distance of the line segment CP squared is r squared is equal to the quantity squared of x sub 1 minus x sub 2 plus the square of the quantity y sub 1 minus y sub 2. I use here P with the coordinates x sub 1 and y sub 1, and C with the coordinates x sub 2 and y sub 2. We have here x sub 1 is 0 and x sub 2 is 3. So we have 0 minus 3 quantity squared plus 2 minus 1 for y sub 1, which is 2, with y sub 2 equals 1. Further, we have r squared is equal to 9 plus 1, with r squared is finally equal to 10. Therefore, the equation of the circle in standard form is x minus 3 quantity squared plus the square of the quantity y minus 1 equals 10. Number 3. Write the equation of a circle having as diameter the line segment from -1, 1 to 3, 4. So we have here the illustration. Again, we need the center and radius of the circle. But with this, we need to take note that we still have to find the center and radius. We denote the given points as P sub 1 and P sub 2. P sub 1 have coordinates 1, -1, and P sub 2 have coordinates 3, 4. The midpoint of the diameter is the center of the circle. The distance between the center and a point on the circle is the radius. Let us solve the center. The center, which is the midpoint between P sub 1 and P sub 2, is solved through h equals 3 plus 1 divided by 2. Where did we get this 3 plus 1? That is from the x coordinates of P sub 2 and P sub 1. That is 3 plus 1 divided by 2. We have h is equal to 2. And k is equal to 4 minus 1 all over 2, which is equal to 3 halves. And 4 minus 1 is taken from the y-coordinate of p sub 2 added with the y-coordinate of p sub 1, which is negative 1. Then we have 4 minus 1 over 2 is equal to 3 halves. With this, it gives us the center of the circle, which is 2, 3 halves. The radius is solved through the distance between the center and p sub 1 or p sub 2. In here, I choose to solve the distance between the midpoint and p sub 2. That is, the distance between p sub 2 and the center to 3 halves is 3 minus 2, where 3 is the x-coordinate of p sub 2, 2 is the x-coordinate of the center, and 4 minus 3 halves is taken from 4, the y-coordinate of p sub 2, subtracted to the k value of the radius. R squared is equal to 1, which is from 3 minus 1 squared, plus 25 over 4, which is from 4 minus 3 halves quantity squared. Then we have r squared is equal to 29 over 4. With this, it gives us the equation of the circle in standard form. That is, the square of the quantity x minus 2 plus the square of the quantity y minus 3 halves equals 29 over 4. This is optional. If we wanted to transform the standard form to general form, we can manipulate the operation and simplify the equation. That is, we have the quantity, the square of the quantity x minus 2 plus the square of the quantity y minus 3 halves equals 29 over 4 can be simplified into this form. X squared minus 4x plus 4 plus y squared minus 3y plus 9 over 4 equals 29 over 4. And if we eliminate the parentheses and arrange the term from highest degree, we have x squared plus y squared minus 4x minus 3y plus 4 plus 9 fourths minus 29 over 4 equals 0. Investigate the equation here. We have terms which are in fraction form, and the general form of the equation of a circle must be in integral coefficients. So what shall we do in here? We will multiply the equation by the LCD, which is 4. Therefore, the general form of the equation of the circle is 4x squared plus 4y squared minus 16x minus 12y minus 4 equals 0. For practice and to explore solving problems on circles, we have here 3 problems. And if you have queries or answers to this exercise, just comment below and don't forget to subscribe. Thank you.